All right, the second example, we have radical, and it is isolated, equals a number minus another radical. Well, there's no way to isolate both of them, so we're just going to start with eliminating the radical that's already isolated. It's a good enough place to start. So I'm going to square the left-hand side. So square root squared cancel. And then everything on the right-hand side is going to be squared. That is very important. But you group it all together. It's the parentheses that are being squared. So now I have x minus 2 on the left, and it equals the parentheses 5 minus the square root of 15 minus x times the parentheses 5 minus square root of 15 minus x. So I have to FOIL the binomial that has the radical in it. And it works just the same as you would FOIL the other ones. It's just might seem a little scary. That's all. So we'll just work through it. It starts off first. 5 times 5. That's no problem. That's 25. All right, so x minus 2 equals 25. And then outside is 5 times negative square root of that stuff. We don't really care what's inside the radical because it's blocked off, protected inside the radical. We're not messing with it. So 5 times the negative is negative 5. So negative 5 square root of whatever. So negative 5 square root of 15 minus x. And then the inside is negative radical times 5. Again, is negative 5 square root of 15 minus x. And then last, negative square root times negative square root. So that's positive square root times square root. That's square root squared, right? Square root squared eliminate each other, so it's just what's left under the radical, 15 minus x. Okay? So then the inside part, we have like in the middle, the middle terms, they should always repeat when you square a binomial. We have negative 5 and negative 5, so that's negative 10. So I have x minus 2 equals 25 minus 10 times the square root 15 minus x plus 15 minus x. Okay. We have more like terms. There's 25 and 15. Those are like terms. We can put those together. So x minus 2 equals 40 minus 10 square root 15 minus x. And there's a minus x on the end. Okay, so now we have an equation that has a single radical in it. So now we can work this one like the last example. We isolate the radical. So to do that, first I want to move the 40 to the left. So I have positive 40, so I'm going to subtract 40 from the right. And I'll subtract it from the negative 2 because those are like terms. And I have a negative x on the right, so I'm going to add x to cancel that out. And I'll add it to its like term on the left. If you want to do that in 2 separate steps, that's fine. I like to do it in a single step. So the right side, the 40 and the x canceled. And on the left side, I have x plus x is 2x. Negative 2 minus 40 is negative 42. And it equals negative 10 square root 15 minus x. All right, so now I've isolated the radical. That's a single term, negative 10 times the square root. Just like 2x is a single term, 2 times x. It's a number times something else. Negative 10 times the square root is a number times something else. There's not a plus or minus in between them, so it's just one term. So that means this is isolated. So I want to get rid of the radical. To get rid of the radical, I'm going to square it. So I have to square the right-hand side. And if I square the right-hand side, I have to square the left-hand side. Okay, so then on the left, I have parentheses times parentheses. 2x minus 42 times 2x minus 42. That equals, on the right-hand side, I need to square everything. So I have negative 10 times negative 10, which is positive 100. And I have the square root squared. So that's just going to give me 15 minus x, and I'm going to put it in parentheses. Because when I eliminated the radical, I turned it into parentheses, because the other stuff is still grouped together. So then I need to FOIL again on the left. So I'm going to start with 2x times 2x. Gives me 4x squared. Then I have 2x times negative 42. Give me negative 84x. Then I have negative 42 times 2x. So again, I have negative 84x. And then I have negative 42 times negative 42, so that's positive 1764. And it equals, on the right-hand side, I have 100 times parentheses. So I'm going to distribute the 100 into the parentheses. 100 times 15 is 1500. 100 times negative x is negative 100x. And then I have like terms in the middle from where I multiplied them together. So if I simplify that, it's 4x squared minus 168x plus 1764 equals 1500 minus 100x. So now I have a quadratic. This is x squared, and there's 3 pieces. I want it equal to 0 so that I can solve it, so I can factor and solve. So everything on the right, I need to move over to the left. So I'm going to subtract 1500 from the 1764, and I'm going to add 100x to its like piece. Now everything's gone from the right. The right side is equal to 0. The left side is 4x squared minus 68x plus 264 equals 0. I have a trinomial equal to 0, so I'm going to factor and solve. My GCF is 4. Whenever you see an A value, go ahead and check. Can I divide everything by 4? Yes, I can. So 4, bring out a 4, and that leaves x squared minus 17x plus 66 equal to 0. So 4, A value is 1, so that's easy factoring. So I'm going to split it into 2 sets of parentheses, split up the x's. When the second symbol is positive, it tells me they're both going to have the same sign. And since this one's negative, I know they both have to be negative. So x minus, 11 and 6. Yes, 11 times 6 is 66. And negative 11 minus 6 is negative 17. So I factored it. So x minus 6 equals 0, so x equals 6. X minus 11 equals 0, so x equals 11. There's my 2 solutions. You need to check for extraneous now. So just come over and check your answers. When x equals 6. When x equals 6, go back to the original problem. It's the square root. 6 minus 2 equals 5 minus the square root, 15 minus 6. That tells me that 2 equals 2. Yes, 2 equals 2. So x equals 6 is a solution. I'm going to check when x equals 11. So I have 11 minus 2, square root of 11 minus 2 equals 5 minus the square root of 15 minus 11. Calculate the left side, it's 3, equals calculate the right side, it's 3. Yes, 3 equals 3, so x equals 11 is also a solution.